Division algorithm for polynomials. You know that a cubic polynomial has at most 3 zeros. However, if you are given only one zero, can you find the other two? For this, let us consider the cubic polynomial x to the power 3 minus 3x to the power 2 minus x plus 3. If we tell you that one of its zeros is 1, then you know that x minus 1 is a factor of this polynomial. As you have learned in class 9th, to get the quotient x to the power 2 minus 2x minus 3. Next, you could get the factors of x to the power 2 minus 2x minus 3 by splitting the middle term as x plus 1, x minus 3. This would give you. So, all the 3 zeros of the cubic polynomial are now known to you as 1, minus 1, and 3. Example. Divide 2x to the power 2 plus 3x plus 1 by x plus 2. Solution. When we multiply x plus 2 by 2x, we get 2x to the power 2, plus 4x. After subtracting both the equations, we get minus x plus 1. Now multiply x plus 2 with minus 1, and we get minus x, minus 2. After subtracting both the equations, we get 3. Note that we stop the division process when either the remainder is 0 or its degree is less than the degree of the divisor. So, here the quotient is 2x minus 1 and the remainder is 3. As you can see that, when we multiply 2x minus 1, and x plus 2, and add 3 into it, we will get the dividend. Therefore, dividend is equals to divisor multiply quotient plus remainder. Let us now extend this process to divide a polynomial by a quadratic polynomial. Example. Divide 3x to the power 3, plus x to the power 2, plus 2x plus 5, by 1 plus 2x plus x to the power 2. Solution. We first arrange the terms of the dividend and the divisor in the decreasing order of their degrees. Arranging the terms in this order is called writing the polynomials in standard form. In this example, the dividend is already in standard form, and the divisor, in standard form, is x to the power 2, plus 2x plus 1. Step 1. To obtain the first term of the quotient, divide the highest degree term of the dividend, that is 3x to the power 3, by the highest degree term of the divisor, that is x to the power 2. This is 3x. Then carry out the division process. What remains is minus 5x to the power 2, minus x plus 5. Step 2. Now, to obtain the second term of the quotient, divide the highest degree term of the new dividend, that is minus 5x to the power 2, by the highest degree term of the divisor, that is x to the power 2. This gives minus 5. Again carry out the division process. What remains is 9x plus 10. Step 3. Now, the degree of 9x plus 10 is less than the degree of the divisor x to the power 2, plus 2x plus 1. So, we cannot continue the division any further. So, the quotient is 3x minus 5 and the remainder is 9x plus 10. As you have learned in previous example that, when we multiply divisor with quotient and add remainder with them, we will get the dividend. So, again we can say that, dividend is equals to, divisor times quotient plus remainder. Let's see another example. Divide 3x to the power 2, minus x to the power 3, minus 3x plus 5, by x minus 1, minus x to the power 2, and verify the division algorithm. Solution. Note that the given polynomials are not in standard form. To carry out division, we first write both the dividend and divisor in decreasing orders of their degrees. So, dividend is equals to minus x to the power 3, plus 3x to the power 2, minus 3x, plus 5, and divisor is equals to minus x to the power 2, plus x minus 1. Now we can start our division process. Divide the highest degree term of the dividend by the highest degree term of the divisor. We get x. Then carry out the division process. What remains is 2x to the power 2, minus 2x, plus 5. To obtain the second term of the quotient, divide the highest degree term of the new dividend, that is, 2x to the power 2, by the highest degree term of the divisor. This gives minus 2. Then carry out the division process. What remains is 3. Now, we stop here, because as you can see, that the degree of 3 is less than the degree of the divisor. So, quotient is equals to x minus 2, and remainder is equals to 3. As we know that, when we multiply the divisor by the quotient, and add the remainder to it, we get the dividend. So, now with this formula, we verify our division algorithm. In this example, the divisor we have, and the quotient we have, and remainder we get. Now after solve this, what we get? We get minus x to the power 3, plus 3x to the power 2, minus 3x, plus 5, which is equal to our dividend. In this way, the division algorithm is verified. Let's see one last example. Find all the zeros of 2x to the power 4, minus 3x to the power 3, minus 3x to the power 2, plus 6x minus 2, if you know that two of its zeros are root 2, and minus root 2. Solution. We know that two zeros of this polynomial are root 2 and minus root 2. This means we know the two values of x, and we have to find out the rest of the values of x. We can write x minus root 2 is equals to 0, and x plus root 2 is equal to 0. Now we need a factor to get remaining zeros of this equation. For this we multiply both the values of zeros we have. After multiply, we will find x to the power 2, minus 2, is a factor of the given polynomial. Now, we divide the given polynomial by x to the power 2, minus 2. So let's start division process. You know, to find first term of quotient, we have to divide higher degree term of dividend by higher degree term of divisor. In this case, higher degree term of dividend is 2x to the power 4, and higher degree term of divisor is x to the power 2. After dividing, we get our first term of quotient, which is 2x to the power 2. Now multiply 2x to the power 2 with first term of divisor and we get 2x to the power 4. Write down this under the term whose degree is 4. Now multiply with second term of divisor and we get 4x to the power 2. Write down this under the term whose degree is 2. Which is 3x to the power 2. Now go ahead with division process. What remains is minus 3x to the power 3, plus x to the power 2, plus 6x, minus 2. To get the second term of quotient, we have to divide the highest degree term of the new dividend, that is, minus 3x to the power 3, by the highest degree term of the divisor, that is, x to the power 2. After dividing we get minus 3x. Now multiply minus 3x with first term of divisor and we get minus 3x to the power 3, write down this under the term whose degree is 3. Now multiply with second term of divisor and we get 6x. Write down this under the term whose degree is 0. Which is 6x. Now go ahead with division process. What remains is x to the power 2, minus 2. To get the third term of quotient, we have to divide the highest degree term of the new dividend, that is, x to the power 2, by the highest degree term of the divisor, that is, x to the power 2. After dividing we get 1. Now multiply 1 with first term of divisor and we get x to the power 2, write down this under the term whose degree is 2. Now multiply with second term of divisor and we get minus 2. Write down this under the constant term, which is minus 2. Now go ahead with division process. Now the division process is complete, because remainder is equals to 0. Now we have both the factors of this polynomial. x to the power 2, minus 2, and 2x to the power 2, minus 3x, plus 1. To find the remaining zeros of the polynomial, we have to solve this equation. To solve the equation we can write it as 2x to the power 2, minus 3x, plus 1 is equals to 0. Now split the middle term, minus 3x. We can split it in, minus 2x, and minus x. 2x to the power 2, minus 2x, minus x, plus 1, is equals to 0. Take 2x as common, you will be left with x minus 1, and here minus 1 as common, you will be left with x minus 1. Now, x minus 1, 2x minus 1, is equals to 0. When we simplify both the factors we get, x is equals to 1, and x is equals to 1 by 2. Now we have all the 4 zeros of this polynomial equation. 2 zeros were given in the question itself, which are root 2, and minus root 2. The rest we have found by solving the question, which are 1, and 1 by 2. Summary. In this chapter, you have studied the following points. Polynomials of degrees 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. A quadratic polynomial in x with real coefficients is of the form ax to the power 2 plus bx plus c, where a, b, and c are real numbers with a is not equals to 0. The zeros of a polynomial px are precisely the x-coordinates of the points, where the graph of y is equals to px intersects the x-axis. A quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. If alpha and beta are the zeros of the quadratic polynomial, ax to the power 2 plus bx plus c, then alpha plus beta is equals to minus b by a, and alpha times beta is equals to c by a. If alpha, beta, and gamma are the zeros of the cubic polynomial, ax to the power 3, plus bx to the power 2, plus cx plus d, then alpha plus beta plus gamma is equals to minus b by a, alpha times beta plus beta times gamma plus gamma times alpha is equals to c by a, and alpha times beta times gamma is equals to minus d by a. The division algorithm states that given any polynomial px and any non-zero polynomial gx, there are polynomials qx and rx such that px is equals to gx times qx plus rx, where rx is equals to 0, or degree rx is less than degree gx. In the next video we will learn about Chapter 3, Pair of linear equations in two variables. Till then, take care and don't forget to like, share, and subscribe our channel. Thank you.